Hello everyone, I'm Daniel Sá, Technical Director of Compass, and I'm very pleased to be here showing a little bit of our company and our software. So, we are a consulting services company specialized in engineering design, in advanced technical consultancy services, and we also develop and commercialize software for numerical simulation, which is called GiD, and which is embedded in GiD's preprocessor and machine environment. So we are a small team, but I believe we are highly qualified and multitasking one, specialized in different industrial sectors. I've been around more than 20 years now, bringing value to our customers with innovative solutions, and we have capacity for large-scale projects with international companies. And we always try to keep close collaboration with technological research centers. We have a very clear mission, just to provide the most innovative numerical analysis solutions and also to satisfy the customer needs in terms of guiding them through the integration of our software among their analysis, design, and production processes. Our vision is to be an advanced technical consultancy reference company, and also to be a high added value simulation software provider for engineering simulations. So we try to add value in engineering services for naval architecture and ocean engineering, but also for several other industrial sectors, as for example for glass manufacturing industry in particular, and also we to computer-aided engineering in general. So, this allows us also to offer tailor-made computer-aided engineering solutions for our customers. As you can see, we have a wide net of customers, resellers, and collaborators around the world. And now I'm going to present you GiD, which is our software, and which is divided in three main modules: CFM, CFD and heat transfer, and RAM series. And among them, there are three, let's say, sub-modules, 12 sub-modules, which can give a solution for structural, flow transfer, couple, FSI, multiphysics, and quite a wide variety of CKP problems. And all of this is integrated in a user-friendly graphic user interface, embedded, as I said before, in GiD, and using the custom lib library capabilities. So that allows to treat the geometry properly and to define all the data on the model. It allows also in the same interface to perform the meshing processes and also to post-process the results. So the first module is CFD and heat transfer. The second main module is RAM series for finite element analysis of structures, and finally CFM for C-keeping analysis. As I said, everything is embedded in a graphic user interface for offering the customer a fully integrated simulation environment. So some of the relevant capabilities of this integrated environment is that it allows to, for example, work with different blocks of the ship in the same office. For example, several people could be working in different blocks, and then all of these blocks with all the structural properties, the materials, the conditions, the load, could be brought together in a single model, importing all these conditions which they were using. So there are some other capabilities involving how the geometry is used for transferring all the information to the actual calculation model. And also it has some particular features and capabilities regarding the structural analysis. So, for example, this is quite a relevant interface in the case of the couple seakeeping and structural analysis, because in the same model both simulation conditions can be defined and the analysis can be launched, as I said, from this unified user interface. So also the same goes for thermomechanical and fire dynamic coupled analysis. And finally, we have this, let's say, research module in which we have been working some years. It's a semi-Lagrangian particle finite element method code. And for the moment, it's being used for some research projects, but we are planning on using it commercially, because as you can see, it promises quite high features and capabilities. So, for example, allows the simulation of moving solids within the fluid, and also of air-water multiple solid interactions, which is quite nice. So regarding the applications, for example, of T9 CFD, as you can see, some simulations of thermo-solar power plants, also of air conditioning installations, so as to define or to analyze the flow rates inside the devices, spot the critical zones and the pressure drops. And also, of course, the CFD, we use it for optimizing hulls for different types of vessels. And also, for example, for assess the areas of high wind resources for installing wind turbines, for example. And regarding web series and the applications of the software, as you can see, for huge structures of vessels, in this case for these container ships, the simulations include coupling with the skipping analysis, so we can include the actual sea condition loads. So as I mentioned before, coupled thermomechanical analysis with fire dynamic simulations, and also for example for monopiles for wind turbines, for simulation of the non-linear properties of the terrain. Regarding CFM, as you can see, all type of different devices for energy harvesting of the ocean, different types of mooring, moving parts of multiple bodies, and also for oscillating water column devices for different companies, and for floating or high performance floating structures, which need a bit of further analysis. So in research projects, in this case coupled with an SPH code for studying the sloshing of water tanks in vessels, or in this case in barges. So as I mentioned before, you also saw before some simulations of huge container ships in different loading conditions and different sea environments. And also very, very interesting are the tightly coupled, in this case with a monolithic strategy, for hydroelastic simulations of highly flexible vessels, as could be catamarans, for example. Also some nice simulations of floating devices, in this case floating solar panels, with a huge number of multiple bodies floating and joined together with different types of connections. And also, as you can see, we have used the software for simulating different types of floating solutions for wind turbines. It could be spar or jackets, floating, different floating devices. So regarding the semi-Lagrangian PFM applications, which I mentioned before, for example, these nice simulations with involving ice on the sea, and you can see navigation of ships in ice, and different types of other simulations for multi-fluid mixing, planning hulls with spray generation, solid fluid interaction, etc. So, hope you enjoyed this presentation, and thanks a lot.